In this video, we're going to focus on converting back and forth between polar form and rectangular form, and then vice versa, rectangular to polar. So what are the things we need to know to be able to do that? Well, everything really goes back to the beginning of our trigonometry journey. We said in the beginning that cosine of theta was equal to x over r, and sine of theta is equal to y over r. So if I were to solve this equation for x, I could multiply both sides by r, so x would be equal to r cosine of theta. So that gives us a substitution for x. Now let's find a substitution for y. We can use sine of theta's definition to help us do that. Again, we can multiply both sides by r, so we're going to get y equals r times sine of theta. Now, we can figure out something for tangent too, because we know tangent is equal to sine over cosine. And we can make a substitution for that. So we have x over r divided by, y over r divided by x over r. And remember, when you divide fractions, you do keep, change, flip. And check this out. Those r's cancel, so we're going to end up with just y over x. So tangent of theta is going to be equal to y over x. That's where that is coming from. It's just using that definition of tangent and rewriting sine and cosine in terms of their definitions. This will help us if we need to make some kind of substitution for a theta value. And then we know that so sine squared plus cosine squared is equal to 1. And we said sine was y over r, cosine was x over r. So we have y squared over r squared plus x squared over r squared is equal to 1. And if we multiply everything by r squared, that's where this is coming from. So all of our definitions are actually coming from things we learned in chapter 6. So let's look at a few examples. So notice these are written in polar form. So we've got our r and theta values. Theta could be written in terms of pi, so in radians, or it could be written in terms of degrees. Either way. So let's look at 39. We want to write this as rectangular. Here's our key. X equals r cosine of theta, and then y is equal to r sine of theta. So x is going to be equal to r, which is 3, cosine of theta. Theta is pi over 2. Well, we know cosine of pi over 2 is 0, so this is going to be 0. Our y coordinate is going to be 3 sine of pi over 2. Sine of pi over 2 is 1, so this is 3 times 1, which is 3. So our xy ordered pair that corresponds to this point would be 0, 3. Now, if we were to graph that, and I'll do a quick sketch here, remember we would move pi over 2, and since our radius is positive, we would move along the terminal side 3 units. So you can see how this point is the same thing as this point if we were to think about placement on that plane. So let's do another one. Let's do number 43. So x is going to be equal to r cosine of theta. R is 6. Cosine of 150 degrees is negative square root of 3 over 2. I'm going to simplify that 2 and that 6. I'm going to get negative 3 square root of 3. Y coordinate is r sine of theta. Sine of 150 is 1/2. So I'm going to get 3. So my XY ordered pair is negative 3 square root of 3 and 3. So what if we want to go the other way? What if we have a rectangular coordinate and we want to find the polar coordinates? It's going to help if we draw a picture of what's going on. So in number 60, we're looking at the point negative 3, 3. Let's start by finding the radius. So the radius we can find by using that equation there, right? And that actually goes back to the beginning of this video where we were talking about that. And it's actually coming from the Pythagorean theorem if you really think about what's going on here. If we were to drop our rectangle down, this would be the x side, this would be the y side. So x squared plus y squared is equal to that radius squared. So there's two ways we could think about this. We derived it using the definitions of sine and cosine and made some substitutions there, but we could also get it from the Pythagorean theorem. So we've got this, which means r is going to be equal to the square root of x squared plus y squared. And the reason I'm going to use a positive square root here is because I'm thinking about the radius. And the radius is a distance. Now, we could write this in terms of a negative r value and then think about what theta would have to be. But if you want to keep it simple, let's do it in terms of a positive radius value. So what is our r going to be? It's going to be the square root of negative 3 squared plus 3 squared. So that's going to be the square root of 9 plus 9, which is 18. 18 is the same thing as 9 times 2. So it's going to be 3 square root of 2. So there's our radius for our problem. So now we got to figure out what theta is. And we can figure this guy out using tangent. Tangent of theta is equal to y over x. And that's something we derived a little bit ago too using sines and cosines. But we also know it from the right triangle trig section that we've talked about. Our y value is 3. Our x value is negative 1. Oh, sorry, negative 3, which reduces to a negative 1. I'm thinking a little bit ahead there. So then what is theta going to be? If I take the inverse tangent of negative 1, I'm going to get negative pi over 4. All right, so you got to think about what's going on behind the scenes, and all the things that we've done up to this point are kind of piecing together. Anytime you find the inverse tangent, you get something that lives somewhere between quadrant 1 or quadrant 4, right? It exists from negative pi over 2 to pi over 2. So we ended up with this guy here, negative pi over 4. So that means that this theta value, we could think about it as pi over 4. But if we're thinking about how am I going to write this in in polar form, then the angle that I actually need is this angle, not the angle of the triangle and not this angle that lives in the fourth quadrant. So not the exact value of this, but I can use that value to help me figure out what this red angle is going to be. So I can take my theta value, negative pi over 4, and I can add pi to it because I'm going from here, opposite of the terminal side, to here along the terminal side. And that's going to give me a 3 pi over 4. So there's my angle value. So then when we think about r theta, what does that have to be? It's going to be 3 square root of 2 and then 3 pi over 4. So let's do another one of those. Let's do 61. So I'm going to scroll down here. 61, we're looking at the point square root of 3, 1. And we want to know what's the polar form for this? So I'm going to start by drawing a picture. Remember, this is rectangular. Square root of 3 is a little less than 2. And then 1 would be somewhere around here. So I moved square root of 3 units this way, and then I moved 1 up this way. Here's my triangle. I want to describe this point in polar form. Let's start by finding r. R is the square root of x squared plus y squared. So the square root of 3 squared plus y squared. So that's going to be the square root of 3 plus 1, which is the square root of 4, which is 2. So there's our r value. Now we've got to figure out theta. And in this case, theta is going to be nice because it's going to live in that first quadrant. We can tie everything together with tangent. Tangent is y over x. That's the same thing as square root of 3 over 3. And we're thinking about the inverse of this. Since we're taking the inverse tangent of something that's positive, we're going to get something that lives in that first quadrant anyway. So we're going to get the theta value that we need from the polar axis to the terminal side of that triangle. And that angle that we're thinking about there. So remember, tangent is y over x. So our theta value has to be pi over 6. So our rectangular coordinates are 2 pi over 6.